Okay, a hearty good afternoon to you, ladies and gentlemen. I am really glad that you have joined us today for this live interactive session with Utthunga Technologies. In the past, FieldComm Group has done many webinars to educate people and, of course, share information about the upcoming technologies of the FieldComm Group. I am here today and I'm very delighted that Jegajith is with us on our show. And this is the second time we are together sharing a screen. Am I right, Jegajith?
Yes, yes, true.
Great. So let me just go ahead without much ado and share some facts about the FieldComm Group. Let's start with a smile. And of course, the picture looks funny without the wires and all the birds perching on them. And of course, it's a very freaky kind of a thing. But when it comes to process control instrumentation, it is all well thought out and well laid out. What we are going to talk today about is a FieldComm group, a very brief introduction, just for people who might have logged in for the first time today. Then we will have a live interaction with Jegajith of Utthunga. And of course, we will have a Q&A session. Please feel free to post your questions as we go along, and we will ensure that all the questions are attended to after the 45 minutes of presentation. Coming quickly to about the FieldComm group, many of you know the FieldComm group because we have been there for quite some time. And FieldComm group is basically a global standards organization. It's a non-profit organization, and it consists of all the, I would say, majority of the process manufacturers, process control instrumentation manufacturers. There are at present there are almost about 380 members of uh, vendor members of the FieldComm group, and of course, FieldComm also interacts and shares the forum with many research organizations when it comes to development work. We work in three domains of the process control instrumentation automation. One is Hart technology, which all of you know of, or most of you know of, Foundation Field Bus, and of course, FDI. And we interact with various developers all over the globe to interact and, of course, make sure that they are able to effectively utilize the standards and develop products based and compliant to those standards. We have a very active chapter here in India, consisting of Anupam, who's the chairman of the FieldComm Group India Society, Weber Shetty, I'm the secretary, and of course, Ravindra Goel is the treasurer. I'm sure all of them are also online at this moment. Just to show you a bigger picture, that look, any technology that is brought in takes care of legacy instruments and, of course, the upcoming technologies. This one screenshot just briefly shows that if you see here the hard devices towards the left, the hard devices have been in existence for quite some time, more than 25 years now. And of course, you have wireless hard devices, which are also there for quite some time now, almost, I would say, a little less than a decade. And you have upcoming technologies like Hart IP. Hart IP has also been in existence for a very long time as a backend for many control systems manufacturers. But of course, Hart IP is now moving to the products as well. And that is what will pave the way for direct usage of Hart through the Ethernet APL onto the main Ethernet bus for process control applications. Now, Hart and wireless Hart are not new to you, for sure. It's a step in the digital transformation of the analog devices. There are more than 40 million devices which are already installed and working worldwide. It's an extremely robust, a simple, and a reliable technology that people have been using. And of course, not to forget that HART is not just about a communication protocol. It gives many, many more advantages, and especially when it comes to diagnostics, asset management, of course, configuration, of course, many other things, diagnosis, etc. So, HART is not just about a communication technology, it's a complete, I would say, an architecture, a backbone for communication in the process control application arena. It's been in existence for more than 25 years, and wireless HART and HART IP are delivering the benefits of Industry 4 and IIoT, something which was not there before, but we had to come out with a technology which can transform the product data directly onto Industry 4 standards and IIoT standards. One more person whom you should know of is Mr. Wally Pratt. Wally is the director of the FieldComm communication protocols. And by the way, just for you to know, he's the actual architect of Hart and wireless Hart test systems. And very, very kicking, and I would say a person who really drives the technology. A wireless and a Hart application won a Plant of the Year award to an Indian company, HMEL Refineries, which is in Bathinda, and we are very proud that they are they won this award, which will be, of course, they'll be felicitated for this award during the automation show. Well, wireless hard cases are already there. I urge you to visit our website, www.fieldcommgroup.org, and you can download this 14-page, I would say, brochure, which shows various use cases studies of wireless HART. And I'm sure you will be more than convinced that this is the technology for the future, and for that matter, extremely robust and reliable. Also, one more thing which you should know is that any product that is developed has to go through a rigorous assessment by the FieldComm group, and these devices are once registered are shown on the website. You can even see which products are registered by going to the website and click on the relevant section, and you can see which are the products or manufacturers which have registered products on wireless HART and HART, of course. Needless to say, it is also there for the other technologies like Fieldbus Foundation and FDI. Today, I'm going to interact with Jegajith of Utthunga, who's an electronics engineer, more than 15 years of experience. He has a proven experience and, of course, has developed many embedded systems. And he's in researching, he's evaluating and synthesizing technical information, I would say from an information stage to a design stage, both for the electronics, firmware, and the software. It's a pleasure and a delight for me, Jagjeet, to interact with you today. So, coming
Thank you, Harish.
to the interactive session of today, uh, I would be asking questions to Jagjeet, and it is my humble submission that whenever you come across any questions or have a query, just please post the same in the comment section, and we will come back to you towards the end of the presentation. So, Jagjeet, welcome to the show, and I would be very happy if you start with some mundane stuff, because I know there is a wide spectrum of people who have joined in, some new and some old. And therefore, let me ask you the first question, which is very pertinent to today's topic, as to what is wired heart and what is wireless heart. Over to you.
Okay. Thank you, Harish, for the detailed introduction about FieldComm Group and introduction about myself. So, yeah, so wireless heart again, it's a version of wireless version of heart. So first, let me say heart. Heart is actually a protocol which is exclusively designed for process automation, and I don't want to go in detail about the heart especially. So heart is basically it is working on an analog signal, and which is having some modulated signal for transferring the digital data. So heart has both analog and digital in the wired heart, and wireless heart when it is coming, it's a wireless version which is actually modulated in 2.4 gigahertz, and that is first wireless communication standard which is exclusively designed for process automation. And again, this is coming into a kind of a mesh network in the sense, as you can see in this the figure, like a device can talk each other, and it can broadcast the data to the final end device. So typically in a peer-to-peer communication, what happens, one node device will communicate back to a host system, and always the host has to communicate to the node. So in that cases, the distance is going to be a limitation. But when it is come to a wireless hard, what happens, even though you are a distance, say, maybe you fix one wireless hard device which is at the maximum distance, and next to that you are keeping another device, even though the distance from the host is more than the what is expected things, because of this mesh topology or mesh connection technology, these devices can talk each other and broadcast the data to the host. That may be the quick introduction about wireless HART.
That means each and every device is intelligent and is basically a router for the information from one product through its own device to the gateway. Am I right?
Exactly. And all this data is collected in a gateway. So gateway can be connected to a PLC or anything on the HMI or any SCADA system. And the gateway again, we can have a different protocols. We can have an Hart IP and a wired Ethernet connection to the system by ensuring all the security layer related to the IP, basically the internet protocols. And on top of it, definitely wireless HART itself is giving a lot of security because the wireless system itself is encrypted.
Mhm. So it's not very important that the product, any instrument that is installed in the field has to have a line of sight to the gateway. I mean, it can communicate through any of the other instruments as well.
Exactly. Because in process automation, I don't think so. We can have a line of sight because most of the time we'll be dealing with the critical system, especially when we talk about oil and gas industry or any other, in that matter, chemical industry. It's not necessary that we will get a line of sight. So definitely, it's not mandatory to have a line of sight for wireless HART. Obviously, it could be in a different locations, even though we have obstacle and other things. With this mesh topology, the multiple device can route the packet to the host and communicate back to the host system.
Jigjeet, can you give us some idea for the benefit of the listeners today about the distances? I would say distances between, the devices, or for that matter, of the overall mesh,
Okay.
or
So
where
distance,
can the farthest instrument be from the gateway?
it is 250 meter, we can say approximately, but it's based on the conditions and kind of noise interference. Sometimes the distance also will come down, but definitely 250-meter is a decent distance which we can achieve in wireless HART. Of course, we are not limited with the 250-meter. When you have a mesh network, definitely with this mesh network, this can be expanded much more. This is something the minimum distance from a gateway or a concentrator to a wireless HART device.
Okay, sounds very interesting, of course.
Yeah.
Uh, Another question that comes to my mind is why the need to migrate from hard to a wireless hard device? Hard devices have been in legacy for a very long time, and there is such a huge installed base all over the country, all over the world, in fact. And yes, of course, people would like to utilize the wireless hard technology also, depending on the applications like monitoring, etc. But why that need really? Can you, say something about that?
Yeah, I just shared the slide also. So there are multiple reasons, Harish. It's not like that. I cannot stick with the one or two reason, but generally maybe I can say one is HART is a standard protocol which is commonly used in the process automation, and there are a lot of standard the communication commands in device specific or anything related to the common commands and other things, which is already pretty much standardized. And based on that, many OEMs build their infrastructure on the HART specific, either on the
Yes.
master side or on the slave side. So when you take one use case, say example, you have some kind of a infrastructure where your existing wired HART is there, where you want to expand it. So definitely there is a wiring effort is required, and this again it has to route in a noisy environment. In that cases, migrating to wireless HART will give a lot of flexibility in terms of installation. Again, one advantage is that wireless HART is operating in extremely low power conditions, so these devices can be also battery operated devices. Say example, I'll give an example of kind of a tank level monitoring system, and this tank could be I would say kind of a 50 feet or 100 feet height. And instead of routing the all the way from 50 feet, these cables, we can have a battery operated wireless HART device which can be fixed on top of a tank for the level monitoring. And we can have a router or another device or the gateway which will get the data. And furthermore, it can connect to HART IP or standard network, whatever it is here. So that is one need. And similar way, like since everything is standardized, compatibility with the existing Hart instead of converting into a different wireless thing. So you know that there are different wireless
Yes.
technologies, right? Bluetooth, Wi-Fi, or in that matter, we can have a custom RF also. So, but
Yes.
again, the compatibility with the existing system, because your entire process automation and the infrastructure has designed which is compatible with this standard. So once you migrate to wireless HUD, of course, all your infrastructure can be leveraged, and so that you don't need to redo anything in terms of the device, especially the DTM or anything on the driver perspective onto the host side. These are the some of
Mhm.
the uh, uh, highlights, or I would say the reason why people are migrating from wireless HUD.
And maybe one of the reasons also is about compliance to NAMUR. I'm sure
Yeah, yeah.
because the world over, the process control instrumentation respects the NAMUR organization and the inputs of NAMUR. And I think this wireless heart also complies to the NE 107 standards.
Yeah,
Very
that is
good.
also
Very
something
good.
good.
Jagjeet, I would like also you to tell me some of the basic components that go in a total wireless system. I mean, that will give an insight to the listeners as to which are all the products that actually make a complete wireless system.
Of course. So even if I talk everything verbally, it's very difficult to reach the audience level. So with the help of a figure, I would like to explain here. So we were talking about the process automation. So the moment when it is means the process automation means a field device. So the first component I would like to start from the field components. The field component could be an actuator or it could be a temperature sensor. That's we can say the field devices, and this field device are going to talk to the router. The similar way, this the field device also have the facility or the capability of doing the mesh networking. It means that even that can also route the packet here and there. But there are devices called wireless router devices, which is exclusively designed for wireless
Mhm.
NAT with a stack that can exchange the data packet from one node to another node. So maybe a couple of field
Mhm.
devices can be deployed, and in between that, if you have a router, the router can route all this data with different field devices. So we have field devices, we have a router, and plus we have a gateway. So gateway means that generally we can say that gateway is a device which is converting one protocol to another protocols. So when we talk about the automation pyramid, definitely the field devices, when you go to the upper layer, this information has to pass to a different model also, right? So in that cases, we will use
Yes.
a gateway devices, and gateway devices will push the data to the upper layer. Then in between that, we have a network access point and network manager. This is nothing but a device which will manage the network. So we can have a different network.
Yes.
When you talk about 100 devices, maybe 50 devices can be a different network, and that can be controlled separately, even in the same field. And we
Mhm.
can have a handheld device also sometimes to configure it, because sometimes instead of connecting wired heart, we need to plug the device to configure something. And in this case, what
Yes.
happens, we can go somewhere close to the field with this handheld
Yes.
device we can connect. So these are some the high level components which is related to the wireless heart.
Mhm. Uh, a question that always is very pertinent when we are talking of such applications is there a chance that you may lose any information at any point of time, or the data is always uploaded whenever the network is live?
Whenever the network is live, definitely the data is available, and the wireless heart is designed in such a way that
Is there
the
a fear
data,
of losing data at any point of time when the network is live?
as long as you have a network connectivity, I think you will not face any data loss
Hello?
in wireless data.
Oh, very good. Question that is a talking point today is about the security of the system. That is, how secure my data is, and of course, how do I make my entire network absolutely secure for operations? Not to forget, we are talking of process control applications, which could be monitoring, maybe high pressure, high temperature applications, etc., etc. And applications can be critical as well. So, tell us something about the security aspect.
See, hard when you talk about the hard, the legacy hard devices, the protocol itself don't have any security features. So the security has to be inbuilt with your first payload of data. So in your application layer, when you have an encryption, you can ensure a data security on that. But when you talk about a set of devices, we cannot restrict ourselves or a system to only limited to a data security. So data security is always possible with a kind of an encryption. But when you talk about the wireless heart itself is having an encryption and decryption, which is through the gateway. So there is an authorization is happening whenever a new device is joining to the network. And similar way with this wireless end-to-end data is encrypted. So the network means that the device is communicated over wireless data on 2.4 gigahertz radio. These data are
Mhm.
already encrypted with AES 128-bit encryption.
And is that also following a kind of a standard,
Yes,
the
that is also
encryption?
following.
So it follows a process control, I mean, 128 character, whatever it is, encryption, basically to ensure that the data stays secure.
Harish, can you repeat that question? I think somewhere
Uh,
I lost the network. Yeah.
I was only wanting to know if that data encryption also follows the process control standards.
Of course, because definitely the process controls. This is exclusively designed for process automation side. So definitely it's follow all the process automation standard and the standard encryption method. And there is no custom technique or any other things which is non-standard is used in the wireless side.
Oh, great. Um, when we're talking of wireless devices, obviously, since there is no cable, the question always is how do you power a device? And if you are able to power a device even through a battery backed system, how long would the battery last? And what is the significance of that? I would ask you, Jagjeet, to highlight some points about the battery life, etc., of the products.
See,
When there's
that's
smart wiring.
a very good question, Harish, because that's what I indicated when the wireless art introduction itself, because these devices can be powered battery operated devices, and there are some use cases from our customer base and as well as our engineering experience. We are able to achieve up to 7 years of battery life with some certain kind of a heartbeat or a data transition. So in that case, precisely I can say like a every 5 to second or I would say like every 500 second or 1,000 seconds. When we are transmitting and broadcasting the data, people are achieved up to 7 years of battery life, and it
Oh,
is up to it's up to the device manufacturer how frequently they are going to transfer the data. And so I think 7 years of battery life is a very good battery life. And there is one more thing when it is come to the wireless art, because these devices are generally used in the hazardous area, especially into where functional safety or intrinsic safety is very critical, or safety critical systems. So in that cases, since this is supported all the intrinsic safety aspects, when we designing
mhm.
such kind of battery operated devices, definitely we need to take care of all the intrinsic safety aspects, because battery means that it's a storage of energy. It should not create any ignition to the field also. Just to adding your point, since you bring that
Yes.
battery on here.
Another thing that something that I talked of in the beginning was, when anyone launches a wireless product, obviously it has to be a tested and a certified one. And FieldComm Group really, kind of takes care that no products are put into the field which are not certified by the FieldComm Group. In addition to just the product certification, I would like to know from you what are the kind of testings that one needs to go for, or the process how to go for, a process to go in for, to ensure that the product is registered, one, it complies to the standard, two, and third, that it is fully interoperable.
So, Adish, this is very interesting question. Even we also, even many times we also face these questions from our customer. How do we certify these things? Even hard and wireless hard devices through FieldComm Group. So, being a leader into this domain, Utthunga has an immense experience into certifying hard and wireless hard devices. So there are two aspects. So I am presenting one screen here, which we will explain the flow. But before getting into this flow, there is an engineering aspects. So when it is come to the engineering aspects, definitely wireless hard and hard devices has to follow the standard as per the FCG. So which answer to basically in a very high level, I would say it has I can divide into two aspects. One is on the firmware side and software side. There are timing standards as per the FieldComm group, and again on the hardware side, basically the physical layer
Yes.
standard has to meet. So the physical layer, of course, when you go for the wireless HART, definitely there are some HART chips are available. Basically, the HART modems are available or wireless HART modems are available. Even though we are using those wireless HART modem, associated electronics has some certain criteria in terms of
Yes.
noise and other power related things. So, in a design perspective, the engineering team or the engineering house has to ensure that these things are taken care. So, being an expert in that subject, Utthunga has a very good experience to do such kind of things, and we have a lot of proven track record. Once that is done, basically your physical layer and the software standard with a 192 test or 193 test for wireless HART, which is a
Mhm.
test device provided by FCG group, and it has some certain procedure to do the test and certain test cases has to pass. And there is a
Yes.
mandatory number of test cases which both wireless and wired HART has to pass, which we can discuss. It's a separate discussion. And once that is passed, this procedure will do it. Basically, we are going to log in and access the FCG portal and raising a product registration
Yes.
ticket and reserve a test slot from the FieldComm group and submission the required registration document. Definitely, this
Yes.
registration document, Utthunga can also help by providing all the test report, both physical layer and as well as the system. Then the testing process and the test report FCG will issue, then registered product packet and product registry. So once a product is registered, the FieldComm Group website itself will register list that product as a registered product. So that's a general
This is
process, and
something
all
that.
yeah, altogether this is a 90 days timeline. So apart from your
Mhm.
product engineering, another close to a 3 months time is required to get a registered wired or wireless HART product.
But that is an assurance to the customer. It's like a confirmation that yes, the product is certified, it is interoperable, it follows the standard, and that there will be no loss of data or information at any point of time. So
Yeah,
all the products once registered can be seen on the Fieldcom Group website as to which are the makes of the company and which products, the specific product codes which are certified by the Fieldcom Group. Good.
yeah.
I'm
You
really
know,
happy
I
about
know.
this.
Yeah, Harish, one more thing, like, whenever we are discussing with our customer also, we will also refer that, these products are already certified and this is something Utthunga engineered the product. So that is also a credit to us when we are
Yes.
seeing, I mean,
In fact,
we
many
are
tender
proud.
documents today specify. Many tender
Yes,
documents today specifically ask for only registered product. After all, who would like
correct.
to take a risk with a product which is not registered? So a good thing always is to register a product. Undoubtedly, I'm very happy about that. One more thing that comes to my mind is we were talking about hard devices, then we were talking about wireless hard devices, and of course, there's a new buzzword which is hard IP. I know that this is a new, faster way of communication and something which is now being pushed down to the product side. So tell us something more about hard IP, please.
Okay, Heart IP, again, I'm presenting one slide. Heart IP is again a very big topic and one of my favorite topic, like APL is also connected with the Heart IP. And so it's a very interesting topic. Maybe you can stop me if I talk too much about Heart IP. Let me restrict myself. So
No,
Heart
go
IP
ahead.
is something like, Heart or wireless Heart protocols on our standard Ethernet. So this is something like that. See, most of the devices which is there in the factory automation or anything on the process automation, now Ethernet is playing a major role because being one of the the protocol which is engineered with multiple factors in terms of the application layer or the what is the network standard or what is the physical layer standard. So Ethernet is significantly penetrated into the automation aspects also. So
Yes.
Hart IP is a flavor of Ethernet version of Hart or wireless Hart. That's what we can say. So the moment when it is when you have a protocols on Ethernet side, definitely we can leverage all the secure practice whatever we are doing for Ethernet side on the Hart IP
Yes.
side. That is one advantage. And second thing, of course, once you have an Ethernet, expanding Ethernet, I think any basic engineer knows that how to expand Ethernet to the field. It doesn't require any kind of a special instrument to expand that. That is also one advantage over Hart IP.
Yes.
And moreover, we start discussing about the wireless heart and our wired heart. So definitely, once this wired and wireless heart into the field level, once it is moved to the factory side, definitely if they want to continue with the hard protocol in the factory
Yes.
environment itself, by leveraging the existing network infrastructure, we can use hard
Yes.
IP. And of course, with the latest trend in the Ethernet or the network standard called APL, which is a new physical layer, which is having a two-wire Ethernet, two-wire the physical
Yes.
layer interface, which is again intrinsically safe or compatible. Where there also we can use Hart IP. So Hart IP also will come to your field with power
Yes.
over data. So
Does it
it's a
also give
vast
some
topic.
advantage in terms of distances again? I mean, maybe a faster network or something like that?
Uh,
Does,
I
in speed and distance?
speed and distance, of course, we can expand in terms of on the Ethernet side. Whatever the Ethernet thing by 10 bar 100, whatever it is getting, or I would say 10 base T1, whatever the distance we are getting, we can leverage that. So when it is come to a APL based device on the physical layer side, it can go up to 1,000 1,000 meter, basically 1 kilometer, and
Mhm.
but that is something coming to that. Otherwise, 10 bar 100, whatever the speed we are getting, and that speed we can get it in hard.
So now critical devices like drives, AC drives, and analyzers, etc., can all be made a part of a very fast network or a controlling network
Yes, of course,
using
of course,
IP,
of course.
hard IP.
Yes, 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 that is true. And moreover, the legacy devices with these kind of routers, so definitely the legacy devices, when they are talking to the upper layer, they can still leverage
Yes,
the hard commands till to the your DCS side.
great. Well, everything is hunky dory and sounds very beautiful, but I am sure all the hunky dory features also bring with them a lot of challenges that one may face when we are implementing, hard wireless or those wireless hard or hard IP in the field. So, can you share with us some of the challenges which one could face when implementing a brownfield project?
Uh, there are multiple challenges we can say when we are implementing wireless HART, especially when we talk about the see. I would say like in an existing device when you are converting into wireless HART, definitely the compatibility of the devices to adapt
Yes,
wireless HART is one real challenge because your device may not engineer to compatible for the wireless HART. Sometimes we may have to go with the wireless adapter. So that time we need to ensure that what kind of communication medium we will be having for this device to communicate back. Generally, we can go with the wireless HART adapter, which will convert your wired HART to wireless HART. But in case a non-wired, non-hard devices is there in the field and which has to convert into wireless HART, definitely we need to design a wireless HART adapter which has a compatibility with the different communication on the device side. So that is an engineering effort. And once that is done, definitely this device has to go for various certification also.
Mhm. So challenges must be very different when it comes to the brownfield projects versus the greenfield projects. In a
Yes,
greenfield, of
yes.
course, you can go for a new device altogether, whereas in a brownfield project, you may have to transform an existing hard device into a wireless hard device.
Yeah, so there is an engineering effort is required, which, as we discussed, certification itself is going to take 90 days.
And
So when you go
how
for
easy is it for a user to do that?
it is depends on their device. Maybe I would like to take one case study here, uh, like where I can present in my screen, where you can see that we were working with one use case is something like that. The customer has a normal standard device which was working in a wired heart, and they really want to take it to the wireless heart. So in that case is what happened, the device don't have any compatibility to make it, like putting an adapter or something like that, so which we need to
Yes,
re-engineer the entire devices by converting into a battery device thing. So when the moment when you're converting into a battery operator device, definitely we need to see all the power optimization and the firmware optimization. All these things has to consider. So it's a time consuming task, but it is a doable thing, definitely, and it is a proven technology. But only thing is the timeline could be, I would say, like the 6 to 8 months time is required to finish that particular activity.
can you also throw some light on the kind of applications that one can go in for with wireless heart, where it has a step advantage over the wired devices?
Yeah, as I started in the beginning, like a tank monitoring devices, where definitely you have a complex wiring, or you need to climb up, or where the safety is very critical for installation and assembly, where we can go for a wireless hard devices which is battery operated. That is one use cases. And second thing, where the kind of area where you're facing a lot of maintenance work in terms of connectivity, because might be having a multiple cabling, and because of the various reasons these cables are disconnecting, or maybe having some fault, because of some
Yes,
electrical reason or something like that. In that cases, definitely it is advisable to go with the wireless card, because we are not changing anything in terms of the infrastructure wise, because infrastructure wise will be complaints with all the standards of the FieldComm group. So these are the
yes.
two cases, Harish, I can highlight quickly.
How
And
about applications like vibration monitoring, corrosion? I mean, there are many applications which have got to do with the health of a device in the field, and I am sure that the end users would always like to know the current health of the device. Can wireless heart devices help us in that kind of a scenario?
yeah, of course. Yes, you rightly indicated that the vibration monitoring and temperature is one use cases where, say, example, the wiring has to
Or
do with a
acoustic
lot.
devices, as they are called?
Yeah, if the wiring has to do with a lot of mechanical instruments, where that's going to be really challenging. In that cases, definitely this wireless art is going to helpful. And similar way for any refinery kind of a project, or anything where you need to have some kind of a modular thing. Like today, you want to plug some devices and acquire some data, you need to plug it somewhere else. In that case, as in ad hoc mode measurements, something kind of on such kind of use case also we can use it. And definitely, when as I told the beginning, when you have a wireless hard device as the handheld device which can be used to configure this device, that is also will become much more easier. So when we talk about
Yes,
a product, we need a frequent maintenance and some kind of an update to the devices, where instead of connecting this device with a wire, which is having a lot of complexity in terms of a technician, there also we can migrate to wireless HART, which will give a lot of which will improve the user experience, again in usability
yes.
perspective, and as well as maintenance perspective, which will reduce the engineering effort, I mean the technician's effort.
I know one of the products for any process plant is the valves or steam traps or valves, those kind of applications which require immense amount of information, well before time, so that the uptime is good, and for that matter, the downtime is minimized to the lowest, or rather have no downtime, or be prepared for downtime during shutdowns. So I think this is something that is really going to help the process users and the companies, the asset managers, to know more about their asset base. Well, all sounding very good, but at the same time, uh, tell us something about what next? What is the roadmap ahead, and what needs to be done? What's your take on that?
Uh, I would say like there are many things are coming. Like definitely one, the roadmap for the Hart and wireless Hart is one is the APL is coming into picture, and APL OPC is there because the moment when you have an APL, definitely from the APL router or devices, we can have an OPC connection which can be connected to the upper layer from L3, L4, and L5. That is the upcoming technology. And second thing, when it is coming to APL, definitely intrinsic safety compatibility is one. I mean, intrinsic safe compatible device with Hart IP is another future. And we are also designing such kind of reference design with APL and Hart IP, which is
Hmm.
exclusively for the process automation side. So these are the highlights, and of course, in future, this is something I'm visualizing. Like with the help of TSN and other things, we'll have more high speed process automation technologies, which will ensure that your data will be delivered on time.
As I understand, I've heard, during Akima, which is scheduled in August this year, uh, FieldComm Group and many companies are showcasing their first level devices or beta level devices which are already on Ethernet APL. So I think this is going to be an exciting future where you will have many more new technologies to cater to dedicated applications, high-speed applications will come in, and at the same time take along the legacy instruments that are already installed in the field. So I think the days are going to be good for the process control engineers, and for that matter, I'm sure there's a lot to benefit from these upcoming technologies. Well, it's been really a good talk with you, Jagjit, and I really appreciate you giving us time. But of course, I'm not going to let you go so easily. I can see that there are a whole lot of questions that are coming in, and people are curious. They want to know more and more about the technology itself. So let me address some of the important questions that have come our way. And the first one, of course, is it comes from Yogesh Patel, who's asking us, what is the frequency of these wireless devices?
2.4 gigahertz.
And that comes under that ISM band, which is actually a
Yeah,
free
yeah.
band.
So it's a free band, 2.4 gigahertz, where our Bluetooth and Wi-Fi is operated in the 2.4 gigahertz.
The ISM
And
is the industrial system, yeah, and the medicine bands.
yes.
Great. So I think that answers your question, Yogesh ji. We have a question from, uh, just give me a second, please. Yes, from Mr. Niladri Shekhar Roy, who's asking us, can we integrate Namur open architecture with wireless heart, which
I
is
think
actually the
you already answered these questions because I missed that point, and I think you answered this. So
yes,
I'm
the wireless
requesting
heart.
you.
Yeah,
Yes, of
go
course.
ahead.
This Namur standard is accepted, and wireless art is also compatible, and Namur is also widely accepted by the process automation. I mean, process automation group.
Great, perfect. Um, our next question is from Lakshmi Hemaram, who's asking us how to secure existing wired hard devices in the factory or in the plant. So it's
Oh, that's a very
something that I
interesting
mentioned.
question, Harish,
Yes,
because when we talk about the security, because you also told almost 20 million devices are connected with the heart, and with the
yes,
increasing connected devices, cybersecurity, and IoT devices, definitely that's a big concern. So the hard device, the hard standard, there is no security standard as of now. In future, maybe some update will come. But what happen?
yes,
How we can ensure that the data from our payload perspective, I would say example in terms of a temperature. When you have a temperature sensor, when you are transferring this data over hard or wireless hard, of course, wireless hard is secured. On the hard
yes.
side, we can encrypt this data on the application side using any of the encryptions so that we can secure. That's a available technique where we can secure the traditional hard interface.
Sure. a question that also came by. This is from Shravani Chakraborty, who's asking, uh, in which areas is wired heart is more preferable uh, than wireless heart? So, where wired heart is more preferred over wireless heart?
That's a tricky
I,
question.
I, I think that's a counter question.
Yeah, that's a counter question. Like actually, wired heart is there in the field maybe 40 years back, Harish. It's
Yes.
yeah, preferably. So in that cases, what happen wherever you have, maybe I have a good answer for that. Wherever you have a device which you have to give power over data, where wired heart is preferred. Say example, the sensors has to power from the field device itself, where we can go with the wired heart because you can power it from the DCS, and the same the electrical connection can be used to power up the data and power up the device and send the data and receive the data. In that cases, wired heart is recommended.
Yeah, maybe all these fast acting loops, etc., which are critical loops, where you need a very fast response time, maybe because then every second counts. So I think in all those fast
Yeah.
acting loops, it may be always advisable to go in for a wired instrument than to go in for a wireless device, which today, unfortunately, it is being used more for condition monitoring uh, or just monitoring applications. Nonetheless,
Yeah,
let's
maybe
move forward. Yeah,
I'll add
please.
one more point.
Yeah,
The
sure.
you started with the actuator because actuator and a similar kind of device where it is need a faster response in terms of uh, anything, any critical conditions as to open and close. Definitely, that could be one use cases. And some of the temperature device because the temperature cannot be transmit like whenever you have a high temperature we
Yes.
cannot take our own time to transfer this kind of a high alert system to the host. So definitely these two use cases is an example for that.
Great. A question came in. Unfortunately, the name is not mentioned, but it's a very pertinent question. And it is asking, uh, does wireless HART protocol work in a master slave mode?
See, answer is yes, because wireless art is also working like I cannot say it's a master slave mode. Basically, you have a field devices and you have a
But on
router.
a token pass. Yes.
Yeah, of course, your the gateway or the router can be push the data to the node devices, and node devices can push the data back to the gateway.
Mhm. Great. A good question coming in from Mr. Ajay Kumar Rao. Sir, good afternoon to you. Uh, can you please share about specific case study for migration of hard devices to wireless hard device through use of an adapter and specific advantage in brownfield projects?
That's going to be a very detailed answer, Harish ji. But I would say there is a one project what we have done for legacy devices, which we need, but by maintaining the hard wired hard port as it is, and on top of it, we have designed an exclusive wireless hard adapter. That is one use cases. And second case study, what we have done, the existing devices, which is a wired hard which we have converted to a wireless heart with a battery operated things. That's what I have shared a part of these presentations, where we re-engineer most of the aspects in terms of hardware. Because the moment when we convert into a wireless heart, definitely the power is the big criteria. So to optimize the power, most of the power electronics and the battery, when it is operating in the battery, the firmware has to optimize to in such a way that it will maintain various sleep operations. So these two case study, maybe after this session, we will share the case study with Ajit Kumar sir, and definitely you can go through this case study. And if you want to have a meeting with us, definitely we are open for such discussion.
Yes. Uh, just to add to what Jagjit has said, sir, I would also like you to please download the brochure from the website, what I mentioned in the beginning of the presentation. It gives a number of applications which can be implemented in the field and on the existing devices as well. So please do download that. It's a free of cost, just a click, and you can download that 12-page brochure, and it gives you various applications. I'm sure it's going to make a good read. A question coming in from Mr. Vamsi Krishna. What are the different network topologies we can use?
I think I have to go back to the slide, but I don't want to present the slide. Definitely, when it is come to the wireless card, the network protocol is basically the field device is going to talk to the router. The route,
Yes,
sorry, the router device are not mandatory when you are when you are using a single network. But when you want to segregate into a different two network, you can have one
yes,
router and many field devices, and you can have a second router and many field devices. And these two router can talk to a gateway, and the gateway can be take abstract this data, and that can be pushed to the upper layer. That's a typical network topology in wireless LAN.
good. Um, a question coming in from Miss Sojanya Vishwal. She's asking, can we do block data transfer from field devices to gateway or application, or there are any limitations in terms of data transfer?
There is no limitation for block data transfer, definitely when it is come to the gateway aspect, because it has to support the block data transfer. Because when you are talking about the gateway, it has reached to a stage that you are going to handle the informations, because it's not limited with one or two devices. There are multiple devices are connected, and definitely we can do the block transfer. And when we talk about the upper layer, definitely we can leverage any other protocol like OPC or anything which can be talked to the
Yes.
cloud. So yes, that is possible.
Another question coming in from Mr. Bhaidoria Mohan Sen Gupta, who's asking that, I think it's a comment which says that end users are generally afraid of wireless hard devices because they're not sure whether the communication is deterministic.
Of course, this is not a deterministic network, that is for sure. And in that case, that's what when during our discussion with Harish ji also we discussed, when as long as you have a network connection, the
Yes,
data will be there. But whenever you have a network issues, definitely it will have its own limitation. But there is a deterministic network we can plan with in terms of hard IP.
yes, for sure. In fact, that's where maybe, wired devices also have an edge,
Yes,
because
exactly.
they are free from the network. Yes. Uh, yeah. One more question coming in. Can wireless hard gateway support hard commands? This is from uh, Sahiti Tuple. Miss Sahiti Tuple.
Of course, when we talk about hard commands, the reason why people are coming into wireless hard to support all the hard commands and other things. So definitely, wireless hard support all the hard commands, which is as per the FieldComm group standard. So definitely, it support all the hard commands.
Great. Well, there are questions still pouring in, but I can also see the clock above ticking away to the end of the session today, and I don't want to kind of hold all the people up beyond the time that we had already envisaged while making this, program. And I would say other questions we can take on sometime later. But I'm really grateful to you, Jagjeet, for giving insight into the technology, sharing some, sharing your viewpoint, sharing some applications, and of course, inciting more confidence in the end users that this is a technology of the future and something which will be here to remain. So let me call it a close for today's session. And I say thank you. Thank you once again, Jagjit, for being a part of this FieldComm group show. And I'm sure there'll be many more opportunities that we can share some information with our customers. So, ladies and gentlemen, that brings us to the end of today's program. And I am sure that we will come back with more such programs in the near future. I thank you very much for your time. I thank you very much for your lovely questions, which also, of course, keeps us totally charged up. We should be able to address them. We should be able to comply to them, and of course, give you our viewpoint as well. So, thank you once again for the time today, and we close today's session. Is that okay with you, Jagjeet, or you
Yeah,
would like
thank
to add
you.
something from your side?
Yeah, thank you, Harish ji, for the relevant questions and the opportunity with the FieldComm group. Definitely, we'll be having more session going forward. Thank you. Thank you very much.
I really appreciate, all the questions are on the dot pertaining to the technology. technology, something which I really feel good about. And I'm sure that makes the technology very exciting for the process control engineers. So stay healthy, stay safe, and of course, take care of yourself. So we call it a day today. Bye, and thank you very much for the session today, Jagji. Yeah,
Thank you. Thank
take
you
care.
very much. Bye bye.